Good morning. Welcome back to the Dawn of Autonomy podcast. I'm Charlton Evans, CEO of End-State Solutions. I'm filling in for Don Zoli this week, and Don will try not to break anything while you're gone. So we're closing out February 2026 AI and Data Month, sponsored by Invictus Technologies and presented by Autonomy Global Network. If you missed the last episode, go check out On Demand on the AGN YouTube channel. Don't forget to subscribe so you get reminders going forward. So we have a fantastic guest with us today, Dr. Yemaya Bordain, Board Executive and VP of Technology at the Advanced Air Mobility Institute. Yemaya is one of those rare people who can move seamlessly between deep technical AI conversation and the policy and governance conversation. And she does it with a perspective that I think is really important for where our industry is headed. Please engage with us in the chat, questions, comments. We want it all. Yemaya, welcome to the show. Great to have you.
Hey, it's so great to be here. Thanks, Charlton.
Yeah.
I'll be kinder. I'll be nice to you still.
Indeed. So let's go into your background a little bit. Folks who may not be familiar with you, we've worked together in the past, and I know you've got a remarkable background between your PhD and some of the studies you've done, and actually how you entered into aerospace and what kind of started that spark for you.
Yeah, I have. It's been an incredible journey so far. I started out in electrical and computer engineering. I was undergrad in electrical engineering. I did computer science for my master's degree and then moved on to electrical and computer engineering for my doctorate. And I specialize in semiconductor device physics. And I went to Intel after earning the doctorate, and there I started working in the embedded aerospace and defense area, where I became the expert at corporate wide in safety critical and safety involved systems. What silicon needs to go into those kind of systems, what the needs are, what documentation we need to provide in order to support the market. And through that, I got to work with many companies, all of the big OEMs and small, anybody that integrates microprocessors into their aerospace and defense systems, both on the ground, at sea, in the air. And then I eventually moved over to a startup called Dedalian. Dedalian was the first company to integrate artificial intelligence on the aircraft, particularly in safety involved and safety critical systems. And I joined them as chief commercial officer and president. And we had a successful exit last year. So I'm now spending my time doing good, thinking about the next chapter for myself, but really continuing on my personal mission to create a safe and secure world.
Yeah, outstanding. Okay. Well, so End-State Solutions has also worked with Dedalian in the past, and we've been more on the regulatory side. And now Yemaya and I intersect in the industry at trade shows and other areas where AI is being covered. And I've got a particular interest in Dedalian's AI-based visual detect and avoid system that I'm hoping comes to fruition soon. So we come from it from different angles, but very complementary, and I think it'll make for a great conversation. So let me refresh everybody on who I am. Former Harrier pilot from the Marine Corps. I first got exposed to unmanned systems while I was a Joint Tactical Air Control in Iraq. Watched many hours of Scan Eagle, Shadow, Predator video, supporting ground operations there. And then I went to lead the type certificate effort at In-Situ with the Scan Eagle. I came back to the US, picked up a job with In-Situ, a Boeing subsidiary, and we ended up pushing the Scan Eagle through a bunch of regulatory work that ended up in commercial work for ConocoPhillips in the Arctic, the BNSF Pathfinder, BVLOS flights, disaster response and relief for hurricanes and wildfires, and we ended up putting that airplane in the Smithsonian, which we're very proud of. I ended up leaving In-Situ founding NSAID Solutions because I saw technology companies with great products, but the technology world doesn't necessarily speak the FAA's language. So we try to bridge that gap. And our tagline is we certify autonomy in aerospace, meaning we can create the safety cases, the ConOps, the certification plans, hazard analysis, all the artifacts that regulators need to see before they say yes to a given approval, exemption, waiver, etc. So we've also done work with Matternet and Chevron, ATI, AeroVironment, many other companies that are in this space that have gotten some historic approvals that, again, we're very proud of. So, Yemaya, you sit at the crossroads of AI, autonomy, and advanced air mobility.
Yeah.
I know you've said before that there was a paper about the Airbus that kind of sparked your desire, your interest in avionics. Tell us about that.
Yeah. So everybody gets to learn now that I'm a total fangirl for the A320 flight controls engineering team. Total nerd. I got introduced into avionics as a whole. I had experience on a different side of aerospace and defense. Beforehand, I was effectively a material scientist. I was developing high performance polymers and composites matrices. And I worked on F-22. I worked with the Air Force. And this was all to develop the carbon fiber materials that would be stronger, that would absorb less moisture, and et cetera. So when I moved over to the embedded side and the computing side, I had no idea what an avionics system was. I remember Googling under the desk when I got this assignment, what is an avionics system? And within 6 months, I was an expert. But one of the papers that really got me motivated was a paper on the fly-by-wire that was installed on the A320 because it was the first experience. It was the first example of a fly-by-wire that got certified. And I remember studying that paper just line by line. I was highlighting the diagrams and the redundancies, the dissimilarities. And from that moment on, I was just like, okay, I need to meet these people. So eventually I did get to work with Airbus in their flight control teams, but I'm a total geek, total nerd and fangirl for these folks for that reason.
Okay. So yeah, that resonates. I mean, we all enter aerospace from different perspectives. I was on the operational side flying, obviously as a pilot, and then developed an interest in unmanned systems and then developed this interest in the regulatory side and certification. So again, very complementary. So let's talk about what our organizations do today. For the audience, how would you describe the Institute's role in the ecosystem of AI and AAM?
Yeah, absolutely. The Advanced Air Mobility Institute is a leading international nonprofit research and advocacy organization. We are, effectively a think tank. We work tirelessly to ensure that as we transition, the world transitions into this new era of flights, we do think that this is, it's really transformative time. That we continue to focus on public trust. We focused on policy excellence, on technology development, and advocacy, but also we want to ensure that we enable access. We want to ensure that when these systems are online, and we are seeing some of them come online and they're in full operations, that they're not only just helping the rich or those that are privileged, but also are helping people that are underserved, or helping folks in rural communities have access to medical supplies much quicker. That we are looking at the entire spectrum of technologies and applications, and then also applying them into the communities and where they can provide a lot of benefit. So, we focus on doing good.
Fair enough. Okay, thank you. So let's tackle the problem that we're facing today, or
Yeah.
the topic, I guess, which is really the AI and the data. A lot of confusion around this, and from where I'm sitting, it comes down to making better decisions with better evidence to support all the certification efforts that we're undergoing. And frankly, it's not just certification, it's across the board. So operations
Yeah.
as well. So I think we can use AI to help teams understand risk, system behavior, edge cases. We've talked about some of that in the past. Things that are hard to do manually that can be
Yep.
enhanced with automation. So I guess what's the biggest misconception you see with AI and autonomy and certification?
Yeah, this is by far, I'm so surprised by the knee-jerk reactions that we often get when we talk about AI and integrating them on aircraft. And it's one that is based in fear, and but also based in science fiction, and also is science fiction. People often, even pilots, we get even aircraft developers who've been doing this for a long time. They get this initial just response, in knee-jerk response, that AI is some kind of wrapper that you bolt on to the aircraft, and it gives the aircraft a brain, and then it takes control of every part of the aircraft. And unfortunately, it's a lot more boring than that. When we talk about applying AI on the aircraft, we don't break the processes, the standards, the rules. We don't break the rules of systems development. We don't break the rules of aircraft development as we do this. We continue to develop aircraft with that are requirements based. And when we integrate AI, it's generally at the components level. It's at the very fundamental building blocks. And instead of a set of if-then statements in a subsystem of a subsystem of a subsystem, it is instead a learned or a trained model that has been locked. And when it goes into operations, it doesn't change going forward. So as we develop these,
Deterministic versus the
yeah.
non-deterministic piece, right? Yeah.
Well, I wouldn't say deterministic versus non-deterministic. AI is deterministic by software standards. Software definition of determinism means that every single time I run some inputs through an operator, and it can even be a black box operator, the output is always the exact same. And the AI, as long as you're running your AI system on hard real-time hardware and hard real-time software, then it is absolutely deterministic. But there's also this, I think, myth that in a non-deterministic component cannot be integrated in a safe system, right? We don't have non-deterministic systems. There are some aspects in components that are non-deterministic components. Multi-core processors being an example of that. I spent many, many years just on that. On multi-core processors. Ethernet is another example. But when we integrate these into systems, we build in mitigations, we build in voting systems, we build in checkers, we build in monitors to make sure, and guardrails to make sure that if they behave in a method that's, or a way that that had not been predicted or previously tested, that we can manage those in a safe and effective way.
I would say that, is it safe to say that the most non-deterministic thing on airplanes today traditionally is the pilot?
I'll let you say that because you are a pilot. I'm not. So I don't get that privilege.
I can tell you, yes, we are pretty non-deterministic, even when well trained.
Absolutely.
So. Yeah.
Yeah, absolutely. The problem here is, as you're dealing with AI, is managing uncertainty, and that's not it's not a novel instance, right? Humans today, human pilots, are uncertain, and in many cases, our environment can be uncertain. And we argue that AI is really the only technology that can manage uncertainty, either as well as a human, in some very specific, potentially narrow cases, better than a human.
Yeah, so I think that's a theme. The more autonomy there is with high design assurance levels, the safer things are in general. I would subscribe to that.
Absolutely.
Okay, so let's take some concrete examples. I know there are many elements of AI that you were working on at Dedalian. One of which that I was very interested in was the pilot eye system, right? Which had many
Yes.
applications. One of which was to detect other aircraft through visual means, and alert the pilot to those. And again, being a human, I would subscribe that pilots in general are not that great at seeing other airplanes in the airspace. And we can debate how well or poorly we do that, but with the pilot eye and radar systems and other systems that are just hardware, unblinking eyes, we can mitigate some of that hard to see part. But then how do we apply the AI in a meaningful way to detect what's an aircraft, what's not, et cetera? Like talk to me about how that works and how it's evolving.
Yeah, we talked earlier about that when we integrate AI, it's at the components level. Well, in this case, of course, for traffic detection, you ultimately want a detect and avoid system. Well, AI is about as good as you can possibly get for a machine to operate either as good as a human or better than a human, on from a perspective of perception, right? We
Mhm.
coined a term, situational intelligence, not just situational awareness. It's not that humans only have a sensor in the form of eyes in order to detect things, but it is that ability to predict the future, to predict when there may be or if there may be an incursion, and to anticipate some potential problems. And that's what AI provides in these cases. So in a detect and avoid system, we would use artificial intelligence in order to do the detection part. In this example, pilot eye, we mounted cameras on the aircraft, one forward facing, two side facing. We gave the system a 270-degree field of view, and it was constantly scanning the skies. But it didn't operate alone. It operated on top of ADS-B. And so, of course, most of your traffic, most of any traffic will be cooperative traffic. Something will have a transponder. Everything flying almost will have a transponder. But then you get those weird cases where, it's non-cooperative. It could be because it's a bird. It could be because it's a hot air balloon. It could be that there's another aircraft that's not that who ADS-B is either broken or it's not available. And so Pilot Eye used neural networks to identify these and then check it against ADS-B, see is ADS-B picking this up? If it does not, then it just generates an alert to tell the pilot, hey, look up and out this way. We think that there is something there.
That's trying to get that system where other systems like it certified. Talk to me about the data requirements, right? So my experience is the FAA never certifies anything by obvious, right? Don't come to the FAA with a black box that does amazing things and say, trust me, it works. There's got to be traceability. There's got to be evidence. You've got to demonstrate to the FAA, and in traditional cases, to a given standard or a prescriptive standard. In this case, that's evolving. So how do you come up with the data that demonstrates that the system's reliable and performs its intended function?
Yeah, well, of course, the FAA and the EASA both. We have a set of standards today that exist for traditional systems that are using the conventional code, and by conventional code, I mean a set of if-then statements, many if-then statements, if-then else statements. And so for the when we integrate AI, we have to take a little departure to handle that our requirements are no longer hard coded. Instead, our requirements are based on data. They go through data, our testing goes through data. And therefore, what Dedalian had done is published some frankly revolutionary papers that it was the first proposed guidance for how to manage that part of your system that is data based. And they coined a term called learning assurance. And learning assurance was the process that you must go through in order for you to ensure that you're using enough data that it represents the real world. The goal is for you to develop an algorithm or a machine learning model that generalizes to the real world, and therefore your test data must be precisely developed such that it is representative of the real world. And then your test data and your training data, they never overlap, of course. And from that point that you identify your test data, and you do that in a very process method, you then will continue to collect data. You're developing your algorithm in lab, so to speak, and you're testing out in the field, and it's a very iterative process. But the learning assurance model, it was a multi-step very systems development approach to managing a data-based component in your overall system. And note that it only manages just the AI component. Everything outside of that, your system level, your subsystem level, all of those follow the traditional DO254, DO178C, 4754, 4761 process. And in fact, of course, 4764 and 4754 and 4761, that obviously that also gets they cascaded into your subsystem and even at your AI level.
Hearing you correctly, it sounds like there's two sets of data.
Yep.
One where you're training and tuning a model in a highly enabled computer enabled environment offline with massive amount of data to try to represent the real world. And then you metaphorically put that in a box when it goes into the operational world. So it's bounded and it's been curated so that it has predictable behavior, even though it was developed in a learning environment. Is that accurate?
That's exactly right.
Okay. So it has been, that makes it a certifiable, predictable, known, transparent, traceable product. Okay.
Yeah, ultimately you still follow your traditional process. Again, you have to do an FHA. You, of course, depending on what safety level you need to meet, you will need more or less data. You'll need more or less redundancy. You'll need more or less dissimilarity. But ultimately, it follows the traditional process, except for the AI component that runs through data, through requirements, through traceability, and the effort that you take, the rigor that you take in demonstrating that it's complete, that it's correct. These are your data sets are complete, that they're correct, and that your model generalizes to the real world is what you need to meet when you stand it up to a regulator.
Well, little side note, I had actually, I would have loved to have had pilot eye on board my glass air aircraft. One day when I was taking off out of our home airport, I actually had a partial engine failure. The engine basically stopped producing thrust. And this was the classic, you're 400 feet off the ground. We're turning out, had a bunch of airspeed on the aircraft, and it just started running really rough. And our airspeed started to decay. I'm climbing out. It was basically an engine failure, although the engine was still running. It just wasn't producing any thrust. There was a plugged fuel line. So long story short is I was able to turn back and land on a crossing runway that just happened to be there as I looked left out of the aircraft. So thankfully, I was able to assess that. And this is the part that pilots play today that we really depend on is we can, through training and skill sets and situational awareness that we're able to process, handle those off-nominal situations. However, had I had pilot eye on board, and there hadn't been a runway right there to turn back to, I would have hopefully been able to have been given a cue to where the best landing spot was, right? In that very compressed timeline. And I'm hopeful that AI tools like that will emerge to give pilots better information faster than we can even come up with on our own.
Yeah,
So
that's the point, right? Pilot Eye, it had a feature that would do detection, but it also did landing guidance, could identify a runway. And this is one example that I think you have to be in the aircraft and you have to see it working in real time to really understand the benefit. I'm not a pilot, but I would often fly when we do our data collection. I would fly in our aircraft and just watch our system running. And I'll tell you, if you don't have experience in the cockpit, you could be like me. And I thought that pilots just had superhuman eyes. And of course, you can see a runway from many nautical miles away. And you get up there, you're like, can you see that? So but here we'd be testing our system, and we could see off in the corner of the screen this tiny little dot, and it was our system picking up a runway, and it was incredible. And then once it picked up the runway, it could lock in on that runway and then provide you with precise guidance on landing the aircraft. But there is another feature as well for emergency landing situations, particularly for helicopters, where the system could identify a clear off helipad landing spot, and but it operated dynamically and in real time. And so imagine losing engine power in a very complex mission and having to initiate an auto rotation. The system could identify a place to land, but then if a tree falls in that spot, the system would automatically update and identify a new place to land. So we think that in particularly if you're flying something like a Robinson 22, where you have 1.9 seconds to initiate an auto rotation, like this could be absolutely critical for supporting pilots.
yeah, so the startle effect is real, having experienced that. And when I had my engine failure, we had ADS-B data, so I could go back and look and see where the airspeed was decaying while I was still climbing as I recognized what was going on and tried to assess that. I'm hopeful again that AI automation or automation in general can reduce that. There would be no startle effect if the Robinson or my aircraft were fully automated and it were being driven to a landing point already when it detected some off nominal or propulsion failure or whatever. So yeah, I'm very hopeful that there's safety enhancements coming in that way. Well, let me take the conversation in a different direction. In the background, obviously, and
Yep.
and I think everyone's doing this to some degree or another or experimenting with it. What about the development of the tools to build the tools with AI? So,
Yeah.
the models are getting better. We're seeing advances in or fewer hallucinations, misguidance. The models seem to be reacting in ways that still require governance and still require backstopping and curation, but they're strong. So I guess where do you see the industry going with using AI tools to help draft the documentation and the code to develop AI and automation tools?
Yeah, when I think about AI and when to use it and where to use it, in particularly in this market in our segment, I think about it as a matrix. There's aerospace, or the business of building aircraft. There's aviation, the business of operating aircraft. But then there's onboard versus offboard, right? And as you dig into those more deeply, you'll find that ultimately there are two reasons or two benefits that you would want to use AI. One is as a productivity or efficiency engine, and that's across the board. This is for developing the aircraft, developing documentation. It could be in manufacturing, getting better efficiencies in manufacturing, identifying defects in manufacturing much quicker. It could also be an MRO and training, right? So defect detection or looking at vibrational modes of engines in order to do predictive maintenance, and then supporting people in training much faster. So productivity engine being one side of it. The other side of it is as a safety enhancement or safety enhancing feature itself in operations, and those generally go on board. So doing things like identifying traffic, and particularly identifying non-cooperative traffic. We've seen recently cases, in one case, just a absolutely catastrophic event of a failure in detecting traffic in the airspace, right? But we also see a lot of examples today where GPS is just not as reliable, and that could also be a huge safety hazard, because so many of our tools and systems in the cockpit rely on GPS and GNSS operating effectively. And but of course, things like landing as well, emergency landing. Imagine, I think the Garmin emergency landing system is absolutely revolutionary. Imagine an AI-based system that's layered on top of that, or working with it, is complementing it. So as we think about those two different ways that AI can be used, I'd often, if you want to gain the benefit of AI as quickly as possible, and not have as much of a regulatory burden, in at least in these applications, but also to reduce your time to market significantly, you want to stick on using it as a productivity tool. Absolutely use it to run through your treasure trove of certification data that you've developed in the past, and train the system in order to know how to build out these documents, how to build out an FHA, or how to build out your process tools.
Yeah.
And I think there you can see very quickly how AI could benefit the segment tremendously. And then on the
Yeah.
safety enhancing side, you're going to have a pretty high regulatory burden for a very good reason. We want to ensure that the tools work and that the models work, but they have to do things that, in cases that they don't work, they should not be pushing the pilot's attention to something that doesn't exist. For instance, if there's a false positive, right? And so too many false positives makes this thing, again, it's a safety hazard. So because of that, you'll have a much higher burden of documentation and rigor in implementing the any AI tools, machine learning, these tools on the aircraft.
Yeah. So to get in all those cases you mentioned, again, it becomes a data issue where the inputs are going to drive the outputs, garbage in, garbage out, right? And you mentioned training for functional hazard assessments or operational risk assessments. All these products or artifacts that have to be developed along the way in certification, in order to avoid um, missteps, unintentional missteps, or bad data coming out. Those systems still have to be trained and curated, right? Or your internal
Yes.
system, whatever you're using, still has to have governance around it that actually backstops, checks, QAs,
Yes.
quality checks, all that. We're not going to just drop humans out of the loop and let the AI come up with an answer, right?
Yeah,
That's
it's
not what
very
you're
difficult to
proposing.
see a world. It's very difficult to see a world where we should drop humans out of the loop. Humans should always have some oversight. At some point, humans will become supervisors effectively. And the point of the human is still there has to be, I believe at least, there has to be a human that says, no, this is wrong. Yes, this is right. And the more data that you get, you said garbage in, garbage out. In this case, you can input garbage, but you must say that that is garbage, right? As long as you label it that it is garbage, then I think that alone continues to help your model to operate better. But you also got to tell it what is not garbage, right? So we have a lot of work to do on just curating the data and annotating the data, but you don't want your model to never see garbage. You actually want to introduce garbage to the model so that it knows that it is garbage. One super easy example, maybe, is if I'm training a machine learning system to identify cats. Well, if I've only shown it cats, when it gets a dog in front of it, it may think that that's a cat. Why? Because it has fur, it has ears, right? It has,
Right.
it may just say fur, therefore cat. No, I have to also say that that's not a cat, or say
Yeah.
that is a dog in order for it to know
Yeah.
that in order for it to operate effectively.
Okay, well, as you blow that out, and you mentioned earlier building models that represent the world as close to reality as we can make them. When you get to those edge cases, right, that aren't just dog or cat, but really, really harder cases towards the corner that we, I think, have to build out. And this is true whether you're talking about a visual world you're trying to represent or a functional hazard assessment. I mean, the same thing. Ultimately, you've got to be able to train the model if it's going to produce a solid output to really identify corner cases, edges of the envelope, all the positives and negatives that you've described. So as we as an industry develop these tools for whatever purpose we use them, I guess generating data that covers those corner cases with all the positives and negatives seems super important, right?
Yeah, definitely. And I'll tell you it's also not just not taking AI into account. It's also not a novel concept that we have edge cases, right? When we develop our systems today, we have times when we're developing systems that have a worst case execution time. You'll get maybe one out of every million instructions will take an additional second, and we have to take that into account, and we have to develop our system to be able to mitigate that when it sees something like that. So we don't give the system an AI based component the license to just do what it wants, right? Everything outside of that AI based component, the decision making, the what do we do next, that then returns back to a set of if then statements and math optimization problems. So, we shouldn't throw AI at something just because you can. You should throw AI only at things that we otherwise just cannot do it without a human, or a machine can't do it.
Well, I guess any other topics you think we should cover for the crowd?
Other topics to cover for the crowd. I think we covered a lot, actually.
There's so much. I mean, we could go down a number of different rabbit holes, but I think we have basically, bottom line is the data has to be curated, the system has to have governance, there's got to be traceability, and it can certainly really enable and accelerate what we're able to do today, both off the aircraft and then on board the aircraft. So I'm looking forward to seeing that all come to fruition in our lifetimes. It's happening very quickly already. Okay, so how do people get in touch with you, Iman?
You can reach me on LinkedIn. You can also reach me by going to my website, www.yemayabordain.com. And there is at the bottom, I believe, is a place where you can plug in your email address and it will come directly to me. So I'm still actually advising many companies, particularly startups on their technology, on their strategies, and I continue to do that in between my time on sewing machines. So I'm looking forward to hearing from you.
Awesome. Yep. And I can be reached at cevans@endstatesolutions.com or via our website or via my LinkedIn profile, Charlton Evans there, and also our End State Solutions page on LinkedIn. So please get in touch with us to ask further questions. I know Yemaya is eager to engage. So are we, and we continue to live at the bleeding edge of this industry for time to come. So thanks everybody very much, and we are out here.
Thank you.